Welcome to this Mission CAT 2020 series of Unacademy CAT4MBA channel. My name is Ronak Shah, and in this session I'm going to teach you the divisibility HCF and LCM. In fact, this is the part 2 of divisibility HCF LCM. So in the previous session we had discussed the basic concepts for this topic, and today we are going to practice plenty of questions, right? In fact, we are going to take some CAT questions as well. So once again, let's quickly look at the agenda of the session. Before that, this is my profile. So I've done my MBA and also in engineering, and I have 12 years of experience, and I've been training students for quantitative ability, verbal ability for various MBA entrance exams. I also guide them for this particular ambition. And these are my team members. So once again, good evening everyone. We have Rajat Kumar with us. Where are the other friends? So this is the agenda. We will quickly revise all these topics. We'll do a quick revision of these topics which we had discussed in the previous session, and then we are going to practice plenty of questions. Hi Nicole. Right, so once again, in case if you haven't subscribed to our channel, that is Unacademy CAT4MBA, please do it right away, and you can also join our Telegram group so that you can be updated on regular basis. Talking about subscription, so you can also go for Unacademy subscription to have continued learning and enjoy many more benefits like mock test series and leaderboard and the personal doubt solving. So these are our plans. You can go for this 1-year plan or you can go for 2 years plan. You can use my discount code SHAH10 to enjoy the benefits. Let's quickly revise this concept. So I hope all of you remember this. So once again, welcome Rajat, Nicole, and Varshini, and Shubhankar, very regular students. Right, so let me help you quickly revise these concepts, guys, because we had discussed that yesterday, so you should remember ideally. Let's see whether you remember that or not. So we had discussed about this factors and multiple. So these are nothing but factors of the numbers, and these are multiples of the number 12, right? So what are the factors of 12? 1, 2, 3, 4, 6, 12. All those numbers which divide 12 perfectly are factors of 12. In fact, do not forget to include 1 and the number itself. They are also their factors. And multiples, so it's like tables. The only thing is it goes on till infinity. Then we had discussed the prime numbers and composite number. So prime numbers, as you understand, from 1 to 100 we have 25 prime numbers, and composite numbers are nothing but composition of prime numbers. So when we multiply different prime numbers or same prime numbers, the composite numbers are generated, right? So we had discussed this point. Also remember this thing that from 1 to 50 there are 15 prime numbers, and from 51 to 100 there are 10 prime numbers, right? Then we had discussed this important concept, prime factorization, that whenever I take a composite number, say 36, so now this 36 is consist of some prime numbers. So which are those prime numbers? So I can say 36 is nothing but 4 into 9. Further, 4 is nothing but 2 into 2 into 3 into 3, right? So 36 can be represented as a power of its prime factors, that is 2 square into 3 square. So in general, any composite number n can be represented in the form a raised to p into b raised to q into c raised to r, and so on and so forth. So this form is called prime factorization. This representation is called prime factorization. Okay. In fact, if you know the prime factorization concept, then you can also quickly calculate number of factors of any number. So before we go ahead with test for prime number, just pay your attention to the concept that we didn't discuss yesterday. So how to quickly find out number of factors of any number. If you want, you can note down this point because this was not discussed yesterday. Number of factors of any number of n, say. So once you have represented n in this form, that is a raised to p into b raised to q into c raised to r, and so on and so forth, the number of factors of n will be equal to this power plus 1 into this power plus 1 into this power plus 1. So this is how you can quickly find out number of factors. So number of factors of n will be power plus 1 into power plus 1 into power plus 1, and so on and so forth. Let me take one example. 36. Let's take a number 36. Now 36 can be represented as 2 raised to 2 into 3 raised to 2. So what are the powers over here? 2 and 2. So number of factors of 36 will be 2 plus 1 into 2 plus 1. That is 9. So there are 9 factors of 36. Now let me quickly write down what are those 9 factors of 36. So please pay attention. It's 1, 2, 3, 4, 6, 9, 12, 18 and 36. See, count this number of factors. They are 9 numbers in total, right? Hi Arunima, good evening. So good to see all of you. So have you understood this concept of number of factors of n? Everyone, show me a thumbs up quickly. Yup, great. Fine. So in case if you have any confusion, you can just type it in the chat box so that I'll explain that concept once again. Okay, guys, show me a thumbs up quickly so that I can make out that my voice is reaching to you. Nicole is always the first one. Then Shubhankar, Arunima. What about others? Rajat. What about Varshini? Are you there, Varshini? Right. So let's quickly look at this test for prime number. So what was that test for prime number? As I explained yesterday, that the normal way of checking whether a number is prime or not. So for example, if I want to check 207 whether it's prime or not, so what I need to do is I need to divide 207 by different prime numbers, 2, 3, 5, 7, 11 and so on and so forth. The question is still what number should we check? So for that, there is a rule which says that you identify the perfect square number closest to this number. So I'll take up 196. Okay, then find out square root of this. It's 14. So that means you need to check for prime numbers in the range 1 to 14. Okay, that's one rule. As it is mentioned over here that you can also check for this thing, that if any number is a prime number, it has to be of this form: 6k plus or minus 1. Every prime number is either 1 more than 6 or 1 less than 1 more than the multiple of 6 or 1 less than the multiple of 6. If that condition is not satisfied, it can't be prime number. But please remember, if a number satisfies this condition, doesn't mean it's a prime number. That's just a preliminary test. Okay, then once you have understood okay, it can be a prime number, then you can apply this test to check whether it's prime or not. Okay, so please remember this point. So I have represented that thing with a set. Okay, all the numbers of the form 6k plus or minus 1 is a superset and prime number is a subset of that. So remember this point. Okay, so here Rajat is saying 6k plus or minus 1 got failed. 6k plus or minus 1 is not working. That means this number is not a prime number. It has to be a composite number. Correct. Right, but even if this test works, then you can go to second step and you can check for this. Right, so I hope you have understood this test for prime number. Then HCF LCM. So the simple rule that you need to remember, HCF is the highest number which divides both the number. So if I ask you what is the HCF of 30 and 40, straight away it's 10, because 10 is the highest number which divides 30 as well as 40. See, 30 and 40 both are divisible by 5, 2, 1, 10 and all. So among them, which one is the highest number, which one is the largest number? It's 10. So that's the HCF. Same way, LCM is the lowest common multiple, matlab a number which is completely divisible by the given numbers. So for example, for 12 and 18, what is the LCM? It's 36. So 36 is that smallest number which is divisible by 12 as well as 18. So this is how you can quickly find out HCF LCM, especially for 2-digit numbers. In fact, we had also discussed some shortcuts for that, so we'll quickly revise that. But once again, remember this formula to find out HCF and LCM of fractions. In case if you miss yesterday's session, then you can always refer to the playlist and you can look at that part 1 video of divisibility, HCF LCM. Acha, one more thing. So in the afternoon, every day in the afternoon at 2 p.m, I am conducting those basics of mathematics session. Okay, so over there also I'm going to discuss HCF LCM tomorrow. So that is afternoon sessions are basics of mathematics session. Of course, some part will be common in this session as well as in that session, but here we go at the advanced level, right? So you will not find that basics of mathematics in the title of the video. So that's the video I'm referring to. Fine. Hi Laksh, how are you? Laksh, sir, can you clear my HCF? Okay, Laksh, you have some confusion about HCF, is it? Fine, so let me explain HCF once again. Guys, just pay your attention in case if you have any confusion for HCF. So if I take two numbers 40 and 50, Tell me, 40 and 50 are divisible by which numbers? Both of this 40 and 50 are divisible by which number? Can I say all the numbers are divisible by 1? So 40 and 50 both are divisible by 1. Same way, both of these numbers are divisible by 2. Then none of this number is divisible by 3. Are both of this number divisible by 4? No. See, 40 is divisible by 4, but 50 is not divisible by 4. So we'll not look at 4 right now. But yes, both the numbers are divisible by 5 and then they are divisible by 10. Are they divisible by any other number more than 10 in common? No. So these are called common factors of 40 and 50. These are the common factors of 40 and 50. Now, what is HCF? Highest common factor. So we need to look at highest number out of this. So it is 10. So this is HCF, the highest number which divides both the given numbers. So now you should be very clear, okay, about HCF and LCM. Guys, if you are not clear about HCF LCM, you can't get even more than 50 percentile. Okay, so please make sure that you are able to quickly calculate HCF LCM. Once again, just to quickly remind you, you should be good at tables of first 20 numbers. For example, if you remember 12 8s are, 14 9s are, 13 6s are, 18 7s and all these things. Trust me, you will be able to quickly calculate HCF and LCM for most of the smaller numbers. So you will not require to waste time. Okay, fine. So then we had discussed some shortcuts for HCF LCM. Acha, so how many methods are there to find out HCF LCM? So we have this prime factorization method. In case if you missed that session, then you can check that. Then I had also shown this method of coprime. This is method of coprime for HCF LCM. Okay, so let's quickly recap that once again, HCF and LCM. So how do we use this method of coprime to find out HCF LCM? Everyone, just pay attention. Okay, I'll give you Laksh. Just pay your attention for time being. So suppose if I ask you find out HCF LCM of these two numbers, say 60 and 75. Okay, what is HCF and LCM? So I can make out that both the numbers are divisible by 5, right? Let me just write it in a different way. So you can easily make out that both these numbers are divisible by 5. So just write down this number in the as a multiple of 5. So 60 is pi into 12 and 75 is pi into 15, right? Okay, now just check whether these two numbers are coprime or not. So yesterday we also had discussed the coprime numbers. What are the coprime numbers? Numbers whose HCF is 1. Okay, so are this 12 and 15 coprime? No, they are not coprime. 3 is the common factor. Both the numbers are divisible by 3, right? So what we'll do is we'll shift that 3 over here. So we'll be left with 4 because 12 is nothing but 3 into 4. We shifted 3 on this side. So now we are left with 4 over here. Same way, shift that 3 over this side. So you will be left with 5, right? Now represent this number once again. So 60 will be 5 into 3, 15 into 4. So 15 4s are 60. Yes, that's correct. Same as 75 will be 5 into 3, 15 into 5. Right? So now check once again whether they are coprime or not. So 4 and 5, yes, they are coprime. That means this 15 is the HCF. Have you understood? 15 is the HCF, right? Now once you have got HCF, then what is the LCM? Make that inverse L shape draw karo, ulta L shape. So this 15 into 4 into 5 is your LCM. It is as simple as this. So for example, if I give you number like this one, 20 and 22, find out HCF LCM. So you can easily make out that 2 is the common factor. So just write down 2 into 20 and 2 into 10 and 2 into 11. Now check whether 10 and 11 are coprime. Yes, they are coprime. So this 2 is the highest common factor. And what will be LCM over here? It will be 2 into 10 into 11. That is HCF into this coprime numbers. You will have to remember this, guys. You will have to remember. Okay, fine. So I hope you have understood this. There's one more shortcut which I had mentioned about HCF LCM, that you can make out HCF or you can judge HCF by looking at the difference between the numbers. Let me give you one more example of that. Okay, suppose I want to find out HCF of this number 30, 45 and 65. find out HCF, right? Now, which two numbers have the smallest difference? Of course, these two numbers has the smallest difference. It's 15. So my HCF will be either 15 or a factor of 15. As simple as that. So are this number divisible by 15? Yes, they are divisible by 15, but this number is not divisible by 15. So 15 can't be HCF. So what are the factors of 15? 5, 3 and 1. Check for 5. Are all these numbers divisible by 5? Yes. So 5 is the HCF. So by looking at the difference, you can also make out what is the HCF. Are we clear? I mean, this was very simple example, but then if you come across, example like question like this one, say 33 and something like 45. Check the difference, it's 12. So HCF will be either 12 or factors of 12, that is 12, 6, 4, 3, 2, 1. So you can make out that both the numbers are divisible by 3. So HCF has to be 3. Right. So hope you would have understood the shortcuts for HCF and LCM. See, we have the normal method to find out HCF, LCM, that is making that table and finding it. Then we discussed that prime factorization method. Then we discussed the co-prime method. Please remember, the co-prime method is used only for two numbers. If there are more than two numbers, you can't use that method of co-prime. Okay. And the fourth one is by looking at the difference, you can make out what is the HCF. Right. So are you all with me, guys? Quickly show me a thumbs up and please press the like button. Everyone, quickly press the like button. Now, yesterday I had given you a question that why do we check for last two digits when we want to find out the divisibility, or when we want to check whether the number is divisible by 4 or not? Why do we check for last two digits? So did you get any answer? So please write down in the comment box, chat box, that why do we check for last two digits as part of divisibility test for 4? What is the test for 2? Check for last digit. If last digit is 0, 2, 4, 6, 8, some even digit, then it will be divisible by 2. Of course, it's very simple. For 4, we check for last two digits of the number. For example, this one, 334, whether it's divisible by 4 or not. So we check for 34, whether 34 is divisible by 4 or not. Okay, so you didn't get any answer for that. Fine. So let me explain this, everyone. Yeah, let me explain this. Okay. Let's look at that part now. Okay, so once again, guys, divisibility rule for 2 is check for last digit. Divisibility rule for 4 is check for last two digits, and divisibility rule for 8 is check for last three digits. So 2, we are very clear, okay, if the number is even, it's divisible by 2. But for 4, why do we check for last two digits? The reason is 100 is divisible by 4. That's the reason. Now, what has it to do with this one? Let's understand. Guys, suppose I want to check whether 648 is divisible by 4 or not. So can I write down the 648 is as 600 plus 48? 100 is divisible by 4. So any multiple of 100 will be divisible by 4. Yes or no? So 600 is definitely divisible by 4. So what do we need to check? Whether this 48 is divisible by 4 or not. If 48 is also divisible by 4, then the whole number will be divisible by 4. And that's the reason we check for last two digits. As simple as that. Same way, 1000 is divisible by 8. So any multiple of 1000 is divisible by 8. So for example, if I ask you 52,024, is it divisible by 8? So what you can think of is 5,224. So we can think it this way, 5,000 plus 224. Now I know 5,000 is always divisible by 8. So what we need to check is whether this 224 is divisible by 8 or not. Yes, it is also divisible. So this number will be divisible by 8. And that's how we check for last three digits of the number. Are you getting this point? Yes, everyone, have you understood this point? Same way, divisibility test for 3 and 9, both are same. You check for sum of digits, right? Now, why do we check for sum of the digits? Why do we check for sum of the digits? The logic is this one. If I take a numbers, say A, B, C. Now in the first session of number system, in the second session of number system, I had mentioned that this is a 3-digit number. So what's the value of this number? It's 100A plus 10B plus C. Yes or no? Right? Now this can be written as, this 100A can be written as 99A plus A. This 10B can be written as 9B plus B, and this C as it is plus C. Now can I say this part is always divisible by 3? Because 99 into something is divisible by 3, 9 into something is also divisible by 3. So what we need to check is whether A plus B plus C is divisible by 3 or not, and this is nothing but sum of the digits. Same way, this part is divisible by 9. So if you want to check whether the number is divisible by 9 or not, what you check is whether this part is divisible by 9 or not. And that's why again for 9, you check for sum of the digits. So this is just a coincidence. Okay? You can easily rearrange the value in this format. And that's why, that's how that test came. You know, कुछ mathematicians ने अपना दिमाग लगाया, इतना सारा दिमाग लगाया, तो उन्होंने ये find करके निकाला. Right? And they must have been awarded for this. Wonderfully. So have you all understood this, guys? Show me a thumbs up quickly if you are with me. I think some of you haven't pressed the like button, guys. Please ask your brother to press that as well. Sab log dabao like button. Fine. So test for 5. Yes, we all are clear. Last digit should be 0 or 5. Test for 10. Last digit should be 0. Very simple. Test for 6. You will check for 2 and 3. Please remember. Test for 12. You will check for 4 and 3. Now please remember, 4 3s are 12. That's correct. Even 6 2s are 12. Na? So why don't we check for 6 and 2? The reason is because they are not co-prime. I repeat, because they are not co-prime. Okay. So whenever you want to create a divisibility rule for bigger number, you will split that bigger number in 2 parts or 2 factors such a way that they are co-prime to each other. Have you understood what I'm saying? So for example, if I want to check whether any number is divisible by 24 or not, what I'll check is I'll split it as 8 into 3. I'll check for 8 and 3. If a number is divisible by 8 as well as 3, that number will surely be divisible by 24 because 8 and 3 are co-prime. See, I could have also split it as 6 into 4 or 12 into 2. But you know, this pair of numbers are not co-prime. So we can't split that way. We'll have to split as 8 and 3. Yes, will you be able to remember this? In fact, guys, I'm assuming that you all have your note and pen with you, that special notebook that we have prepared for all the important points. So make sure that you are writing down all these points. Okay, whatever points I have mentioned, you are noting it down because you will require to do periodic revision. Okay, so please write down such points, and whatever you feel important, you can either write it at header, on the header, or you can put a box around that. Do some decorative work, that's perfectly fine. But remember these points at least for 1 year till all your exams are over. So prime factors have to see. Okay. Now guys, there are some questions. So quickly tell me which of the following are prime numbers. Please enter your answer in the chat box. Check each number one by one and tell me which of this is prime. Of course, 172 is not prime. It's an even number. What about 253, 299, 101 and 629? Tell me whether 253 is prime or not. Quickly. Everyone, I'm waiting for your answer. Put it in the chat box. Yeah, Shubhankar, what's your doubt? Please explain for 9. Okay. Shubhankar, for 9 we check for the sum of the digits. If sum of the digits of the number is divisible by 9, then the number will be divisible by 9. Right? So for example, if I want to check whether 729 is divisible by 9 or not, so what I'll do is I'll add this digit 7 plus 2 plus 9. So 7 plus 2 plus 9 is 18. So 18 is divisible by 9, and that's why 729 is also divisible by 9. Right. 101 is a prime number, right? So 101 is a prime number. What about others? 253, is it prime? No, Arunima, it's not a prime number. It's divisible by something. It's divisible by 11. In fact, guys, we didn't discuss the divisibility test for 7 and 11. So please pause. Let me explain this divisibility test for 7 and divisibility test for 11. because these are very important. We missed that. So just pay attention here. How do we check whether any number is divisible by 7 or not? So suppose I want to check whether 343 is divisible by 7 or not. So what I need to do is I need to look at the last digit, make double of that. So 3 2s are 6, right? And subtract that result from the remaining number. So 34 में से 6 subtract कर दो, right? So what is 34 minus 6? 34 minus 6 is 28. Is 28 divisible by 7? Yes. So this number will be divisible by 7. Let me take one more example. I'm sure there must be some confusion now. Let's take one more example. Don't worry everyone, I'm there to help you out. So let's take 1281. Okay, so look at the last digit, make the double of that. Please listen to me carefully, everyone. Please listen to me carefully. Don't solve any question right now. पहले हम 7 and 11 का divisibility test देख लेते हैं. We missed that. So 1281, is it divisible by 7? So that is what we are checking. So last digit is 1, make double of that, so it's 2, and subtract that result from the remaining number. So 128 में से ये 2 subtract कर दो. What will be the result? It's 126. Now, is 126 divisible by 7? If you're good at table, you can straight away say it's 18 sevens are 126. But suppose you are not able to figure out, then again take the last digit, make double of that, and subtract from the remaining number. You got 0. If you get 0 or a multiple of 7, that means number is divisible by 7. So even 1281 is divisible by 7. Have you all understood this test for 7? Yes? Okay. So now let's look at test for 11. Test for 11 is very simple. A, B, C, D. If I take a number A, B, C, D, what I need to do is I need to add the alternate digit. That is first digit, third digit, and so on and so forth. Just add them and write it down. Then add the second and fourth digit, that is again alternate digit we added, so B plus D, and check this difference between these two results. If this difference is 0 or 11, that means this number will be divisible by 11. So for example, let's take this 253. Alternate digit summation is 2 plus 3, 5, minus this, see we added these two digits, minus this digit, it's 5, because here it's a 3-digit number. So in one addition we had 2 plus 3 and there is just a single digit. So 5 minus 5 is 0. So that means this number is divisible by 11. So by looking at this number you can make out it's divisible by 11, right? Let me take one more example. Suppose it is 7 to 4 9, something like this. So what is the first number plus third number? It's 11. What is second number plus fourth number? Again it's 11. What is the difference? It's 0. So that means even 7249 is divisible by 11. Yes, have you all understood this, guys? Yep. So show me a thumbs up quickly. So we have completed almost all the concepts related to HCF LCM divisibility which are important for CAT. The only thing is now HCF LCM divisibility, the questions that are asked in CAT exam has lots of variety. So now we need to look at about 25-30 different questions, varieties of question. And then after the session, you can again practice more question. So if you want, you can practice it from Arun Sharma. You can also refer to the Proton Training Solution material, whatever you like. If you are subscribed to Unacademy Plus plan, then you can access mock test and other tests over there. So you can ultimately practice to the questions. Okay, fine. So I hope you have understood this. So this is not a prime number. This is not a prime number because it's divisible by 11. In fact, check for 299. Is 299 a prime number? Guys, let's check. So 299, what is the closest square root? It's 289. What is the square root of that? What is the closest perfect square number? It's 289. So what is the square root of this? 17. That means we need to check for prime numbers in this range 1 to 17. So let's take the prime number 2, 3, 5, 7, 11, 13, 17. That's it. The number is not divisible by 2, not divisible by 3, because if you look at the sum of the digits, it's 20. So not divisible by 3. 5 by checking last digit, not divisible. 7, so 9 2s are 18. 29 minus 18, it's 11, not divisible by 7. 11, check for alternate digit summation. 2 plus 9, 11, minus 9, it's 2. It's neither 0 nor 11, so not divisible by 11. 13 divided by 13, so 299 divided by 13. 13 2s are 26. Okay, 3, 9, 13 3s are 39. Perfectly divisible. right? So this number is not a prime number because it's perfectly divisible by 13. 13 into 23 is 299. Yes. So 101, yes, that's a prime number. 629 is also not a prime number. Okay, it's not a prime number, it's divisible by something. Okay, so there is only one prime number. So I hope all of you could identify this. Now this one, please quickly write these numbers in the prime factorized form. Everyone quickly do it, the prime factorized form. Shubhankar was supposed to paste a poem. The poet Shubhankar, you had promised a poem. Yep. Okay, so guys, what is the prime factorized form of 400? Now here there is a point, an important point. You are going to use it extensively in CAT exam. So remember this point. 10 is 2 into 5. 100 is 2 square 5 square. 1000 means 2 cube 5 cube. So please understand, a pair of 2 and 5 produces a 0 at the end of the number. Two pairs of 2 and 5 produces 2 0 at the end of the number. So 400 can be thought as 4 into 100. Now we know 100 is nothing but 2 square 5 square. What is 4? It's nothing but 2 square. So how many times do you see 2 in this? 4 times. So 2 raised to 4 and 5 square. As simple as that. Can you do it this way? So for example, if I ask you to prime factorize this number 120, okay, see how can we do it? This 0 is there, that means there is 2 into 5 and this is 12. So what is 12? 2 into 2 into 3. So what is the prime factorized form of 120? It's 2 cube 3 square into 5 raised to 1, right? 2 is coming 3 times, 3 is coming 1 time and 5 is coming 1 time. Correct, everyone? So this is the shortcut that you will use. याद रहेगा ना सबको? Fine, great. Yeah, someone has recently joined. Who is that? Show me a thumbs up so that I can know your name. So once again guys, this is the daily life of Unacademy CAT channel, and where you can get completely prepared for your CAT and other MBA entrance exams, not only for quant, even for verbal, logical listening and data interpretation. As I told you earlier, we are soon starting this session. So I just spoke to that faculty and we'll be starting this LRDI session mostly from Wednesday for sure. So till then you make sure that your number system gets over, right? Yeah, Arunima, you want me to explain that once again? Fine. What I said is, whenever you see a 0 at the end of the number, understand that there is 2 into 5. If you see 2 zeros, so there has to be 2 square 5 square, because this 2 0 indicates 100 and 100 is nothing but 2 square 5 square, right? So 400 is nothing but 4 into 100. This 100 is 2 square into 5 square. And this 4 is nothing but 2 square. So that's how you can quickly get 2 raised to 4 into 5 square. So for example, if I ask you to prime factorize this number 3600, straight away you can make out that 2 zeros means it's 2 square 5 square. And what is 36? So 9 4s are 36, 9 is 3 square and 4 is 2 square, right? Because 3600 is nothing but 36 into 100. So we first wrote the prime factorization for 100 and then we wrote for 36. So the complete prime factorization of 3600 will be 2 raised to 4 into 3 raised to 2 into 5 raised to 1, 5 raised to 2. Yes, have you understood, Arunima? Are you clear with this point? Please note down in your diary, okay, in your notebook, and please practice it. Think take some different examples and apply it over there. Okay. Yeah, Shubhankar, you have disappeared. Are you there? Shubhankar? Yeah, because I asked you to write a poem. You mentioned that you will get us a poem. Isn't that? Fine, I was just kidding. But if you have, you can always paste it over here. Okay guys, so same way 888. Tell me what is prime factorization of 888. Everyone, try it quickly, and then 216. So 888, it's 8 into 111. 8 is 2 cube. Now 111, of course, it's divisible by 3. So 3 into 37 is 111. So this is the prime factorization of 888. 2 cube into 3 raised to 1 into 37 raised to 1. Okay. Right, you already did that, is it? Now 216. So yeah, what happened? Why are you not able to send, Rajat? Is there any issue? What is 216? So you should know 216 is 6 cube. And what is 6? It's 2 into 3. So 216 is nothing but 2 cube into 3 cube. Right? So for example, 64, you should remember that it's 2 raised to 6. If I say 256, you should remember it's 2 raised to 8. So you need to remember, few things in your mind. As I mentioned in the previous session, that you need to remember powers of 2 raised to 1 to 2 raised to 10, then 3 raised to 1 to 3 raised to 6, 5 raised to 1 to 5 raised to 6, and so on and so forth, so that you can quickly solve the questions. Right? Okay. So guys, now let's quickly look at the next question. So we have already prime factorized these numbers. We have already written that. Now, these are the prime factorized form. Now look at this question. Find the highest power of 2 that will completely divide this number. So what is the power of 2 in prime factorization of 400? It's 2 raised to 4. So highest power of 2 that will completely divide this number is 4. Because it has 2 raised to 4 in that. Same way, highest power of 2 that will completely divide this one is 3. Because it has 2 raised to 3 in it. So what is the highest power of 3? That includes in this number, highest power of 2 that is included in this one, it's 3. You need to write this way. You don't write 2 cube because 2 की तो power पूछी है. So आप सिर्फ 3 लिखोगे यहाँ पे. Same way, it's 3 over here. Because we know what is the power of 2 in this number, it's 3. What is the power of 2 in this number, it's 3. What is the power of 2 in this number, it's 4. Right? Okay, fine Rajat, it's okay. It's okay. Focus on studies first. Fine. Yeah, so guys, before we move on, just quickly for your information, in case if you are not aware, then I also conduct special classes on Unacademy platform. You must have downloaded Unacademy app, and you can find me by the name Ronak Kumar Shah. Ronak Kumar Shah on Unacademy platform. Download the app and find me by this name, and then follow me, so you will get updates about my special classes and your learning will continue over there. Apart from that, I'm going to conduct few marathon sessions over there, and you will also come to know about my new batches and new courses on Unacademy platform. So please attend, follow me over there as well. Arunima gave me one head today. Thank you, Arunima. Arunima dedicated a head to me. Right? Smiley. Thank you. So felt appreciated. Okay. So guys, find the number of common factors for 60 and 90. So this is a simple question. Number of common factors of 60 and 90. So which are those factors, which are those numbers which divide both the given numbers? So can I say both the numbers are divisible by 1? Then 2, then 3, then 4. 4 से नहीं होगे, both the numbers are not divisible by 4. So 1, 2, 3, then 5, right? Then 6, then 10, 15, 30. So these are the common factors of this number. So how many numbers are this? Count them. 1, 2, 3, 4, 5, 6, 7, 8. So the number of common factors are 8. Please note down this thing. So this with this example, you all should be very clear what is factor, what are the common factors and all. Don't make any silly mistakes. Okay guys, so as you would be aware about that, okay, on the Plus platform, on Unacademy platform, if you watch certain videos, you accumulate certain minutes, and then you get many benefits. You can utilize those minutes. You can earn credits. You can also dedicate it to faculties. So you can pass on the head to me, and that's a token of appreciation. So whenever our team meeting happens, they all check which faculty has how many heads, right? So their students, if their students appreciate that, so that's how it is being checked. So that's wonderful for me. Right, so I'm sure all of you are clear with this point. Now let's look at this one, HCF and LCM of this number. So quickly find out HCF LCM of all these numbers. Everyone, please find out HCF LCM of all the numbers. It should be very fast. Hi Akash. Why are you late today? Yeah, so guys, you need to tell me HCF LCM of these numbers. What is HCF LCM of 35, 45? What is the difference? 10. So of course it can't be more than 10. It has to be less than 10. By checking, you can make out HCF is 5. So once you have got HCF, so now you can say 35 is equal to 5 into 7, and 45 is nothing but 5 into 9. And once again, you can see these two are co-prime. So what is LCM? 5 into 7 into 9. Just draw that reverse L and you are through. So 5 7s are 35, 9s are, what is 315? Isn't that? So LCM is 315. Correct. No, 10 is incorrect. HCF is 5, LCM is 315. Right. Now for this one, 140 and 240, you can easily make out HCF is 20. Both the numbers are divisible by 20. Even the difference is 20. Now 140 is nothing but 20 into 7. 240 is nothing but 20 into 12. Correct. So these two are co-prime. Yes. So make that L. So LCM is equal to the 20 into 7 into 12. As simple as this. So 12 into 7, 84. 84 2s are 168. पीछे एक 0 लगा दो. So it will be 1680. As simple as that. Yes, guys, have you all got this answer? Same way you can try for these two questions later on. Okay, if you want, you can quickly note down, and we'll go to next question because these are easy question. I'm sure you can tackle it. We will take up some really challenging questions. Even this one is an easy question. 5 6a is divisible by 3. Find the possible value of a. So of course this sum of the digits, that is 5 plus 6 plus a, should be divisible by 3. For this number to be divisible by 3, a is the units digit, so a's value can be 0 to 9. Now 5 plus 6, it's 11. So 11 plus 1 will be 12 and it will be divisible by 3. So a can be 1. Or 11 plus 4, 15 divisible by 3. So a can be 4. Or 11 plus 7 is 18, which is also divisible by 3. So a can be 7 as well. So the possible value of a are 1, 4 or 7. Correct? Everyone, show me a thumbs up. It has been long since you haven't shown me a thumbs up. Yep. So is this number divisible by 24? How do we check whether a number is divisible by 24 or not? Check for 8 as well as 3. What do we need to do for 8? Check for last 3 digits. Number formed by last 3 digits. So 432 can be written as 400 plus 32. Can I say 400 is divisible by 8? 32 is divisible by 8. So this 432 is also divisible by 8. Yes or no? So that means this complete number is divisible by 8. एक टेस्ट तो हो गया. अभी हमें 3 से भी चेक करना पड़ेगा. We'll have to check for 3 as well. So for 3 you will have to add all this digit. Add all this digit, and if you add them, that summation will come out to be 45, which is again divisible by 3. So since this number is divisible by both 8 and 3, this number is divisible by 24. Correct? आसान सा क्वेश्चन था. आगे बढ़ते हैं. अब यहाँ पे मैं आपको इंपॉर्टेंट पॉइंट देने वाला हूं, तो अपनी वो डायरी ओपन रखना. If a number is divisible by 4 and 6, it must be divisible by 24. False. Simple. Why? let me take some numbers which are divisible by 4 and 6. So it can be 12, it can be 24, it can be 36, it can be 48. Can I say all these numbers are divisible by 4 as well as 6? Are all these numbers divisible by 24? No, this is not divisible by 24. This is not divisible by 24, right? So that's why this statement is not necessarily true. Must be likha hai. It can be, but not must be, right? Okay. Now here there is a rule which you need to remember. Okay, the rule goes something like this. If you want, you can write down this thing. If a number n is divisible by a and b, okay, this a is different, it's an article, while here I am talking about two different numbers a and b, then it will always be divisible by LCM of a and b. Yes, this is the point. Please write down this thing. If a number is divisible by a and b, then that number will always be divisible by LCM of a and b. See here, this number is divisible by 4 and 6. What is the LCM of 4 and 6? LCM is 12. The lowest common multiple is 12. So that means that number will always be divisible by 12. But whether it will be divisible by 24 or not, we can't say. Correct? So this is the point that you need to note down. Yes, are you all there? Rajat, Varshini, Nicole, Shubhankar, Arunima, Akash. Where are you, Akash? Left? You came just now and you left? दिल तोड़ी है यार तुमने. Okay. Yep, guys. Have you noted down this point? Type yes in the chat box if you have written this point so that we can go to the next part. Great. Let's go to the next part. How many numbers less than 30 are co-prime to 30? How many numbers less than 30 are co-prime to 30? Okay. Now this is slightly a tricky question. Present, sir. Great, Akash. Okay, fine. Be there. Keep learning. Now guys, stop writing and just pay attention because this is a tricky question. In fact, I'll also give you a CAT question after this question. Okay, if you have understood this concept, then you can also solve that CAT question. How many numbers less than 30 are co-prime to 30? First of all, what are the co-prime numbers? Numbers whose HCF is 1, or the other way of looking at that, if I take two numbers and there is no common prime factor in those two numbers, that means they will be co-prime, right? So I need to find out how many numbers in the range of 1 to 30 are co-prime to 30. So let me prime factorize 30. What is 30? It's 2 into 3 into 5, correct? Means this 30, number 30 has 2 in that, 3 in that and 5 in that, correct? So from 1 to 30, I can't take any number which has 2 in that or 3 in that or 5 in that. That means I need to exclude all the even numbers. I need to exclude all the multiples of 3 and I need to exclude all the multiples of 5. If I take any even number, of course it can't be co-prime to 30, or if I take any multiple of 3, it can't be co-prime to 30, or if I take any multiple of 5, it can't be co-prime to 30, right? So how can we do it? One way is, of course, you can check if 1 is always co-prime to all the number. Then we can't take 2, we can't take 3, we can't take 4 because 4 has 2 in that. We can't take 5. 6 नहीं ले सकते because 6 has 2 in that. We can take 7, right? Then 8. So let's keep all the even number, 8, 10, 12. Let's keep all the even number. Now in the odd numbers also, we can't take odd numbers which are multiple of 3 or 5. So we can't take 9, 11. Yes, we can take 13. We can take, but 15 we can't take. 17, 19 we can take, but 21 we can't take because 21 has 3 in that. Then we can take 23, again 25 we can't take, 27 we can't take, we'll have to take 29. So see how many numbers are co-prime to this 30. These are those numbers which are co-prime to 30. It was a long process, isn't that? So I'll show you the shortcut, guys. But please understand the concept. So these numbers in the range 1 to 30 are co-prime to 30. How many numbers are there? 2, 4, 6 and 8. So there are 8 co-prime numbers. 8 numbers which are co-prime to 30. Have you all understood this point? Show me a thumbs up first of all, because this is a tricky point. So I quickly went through that, assuming that now you understand what are the factors, what are the prime numbers, and what are the co-prime numbers. If you understand these three things, the explanation that I gave, you should have understood that. So show me a co-prime number. Show me a thumbs up, not co-prime number. Yeah, Rajat, what's the problem? What's happening? Is it showing loading to everyone, guys? Yeah, great. Good to see. What about you, Akash? Have you understood this point? Great. Fine. So this was a long method. Now, what is the shortcut for this? So understand this part. See, from 1 to 30, we need to exclude all the even numbers. So can I say there are 15 even numbers? We don't need to take those even numbers. We need to take only remaining 15 odd numbers. Yes or no? So we will take this 15 odd numbers. Now these 15 numbers are 1, 3, 5, 7 up to 29. Out of this 15 odd numbers, there will be 1/3 number which will be multiple of 3. We need to exclude them because we can't take multiples of 3. So what is 1/3 of 15? It's 5. So we need to exclude those 5 numbers and we need to take remaining 10 numbers. Okay, so from 1 to 30, check which are the odd numbers which are multiple of 3. So it's 3, 9, 15, 21 and 27. These are 5 numbers. So we need to exclude those 5 numbers. Okay, we need to include this 10 numbers. Now out of this 10 numbers, there will be 1/5 number which will be multiple of 5. So what is 1/5 of 10? It's 2. We don't need to take these 2 numbers. We'll take remaining 8 numbers. That's it. So if you have purchased any book, right, whether Arun Sharma or you have purchased books of some other academy, whether it's Time or Proton Train Solution, any of the academy, right, in that you will see one formula, something called phi of n. Phi of n is equal to n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c and so on and so forth. Now this is a complicated formula. Okay, so what is this formula? So phi of n indicates number of coprimes less than n. Number of coprimes less than n. So this is this formula. We will get into this formula afterwards. So if you want, you can just note down this thing and you can try to understand what are this a, b, c. A, b, c are the prime factors of n. So here if I take n as 30, so the prime factors are 2, 3, 5. So my a will be 2, b will be 3 and c will be 5, right? Yeah, Rajat, so that's why we have this formula for that. I was just trying to explain you the concept first. And this is the direct formula to find out. So if I want to find out number of coprime to 30, I can straight away take phi of 30, which is equal to 30 into 1 minus 1 by 2 into 1 minus 1 by 3 into 1 minus 1 by 5. Find out this thing and it will come out to be 8. As simple as that. Acha. No, Rajat, when you will practice, you will remember this. But for CAT, yes, I'll suggest that you remember this point. Many a times this kind of question have come where you need to straight away find out number of coprimes less than n, right? So just take a deep breath. Tomorrow in the morning, you sit with this video once again. Watch this video twice and you will understand this part. Trust me. Because I have explained the complete thing in a step-by-step manner, so you'll surely understand that. Are we clear? Everyone? Now show me a thumbs up. Yeah, that's great. So the LCM of two numbers is 2310 and their HCF is 30. If one of the number is 210, then find the other number. Right. Okay, guys, tell me one thing. Shall we stretch for half an hour more? Shall we complete these questions? Because we have just started and there are about 15 more questions. So do you have capacity? If you want me to continue till 10:30, you show me a thumbs up, we'll go ahead, right? It's a live session, it's for the live learners. So show me a thumbs up if you want me to go ahead till 10:30. It's up to you. Fine. Yes, Akash is saying yes. How about others? So see, let me show you how many questions we need to complete. Let's count it first. So we'll start with this one. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 questions. And these 8 questions are of 8 different varieties. As simple as that. We have just started with the CAT level. और 10 बज गए. तो पर हमें कंटिन्यू तो करना ही पड़ेगा. तो चलो करते हैं फिर. टॉपिक तो खत्म करना ही है आज. राइट क्योंकि HCF LCM को हम 2 पार्ट से आगे ले ही नहीं जा सकते. नहीं तो फिर हमारा जो प्लान है 2 महीने में कैट का पूरा सिलेबस खत्म करने का वो होगा नहीं. राइट सो प्लीज बी विथ मी. राइट रजत, you are always with me. You should have been in Pune, Rajat. We would have been good friends. Yeah. So guys, LCM of two numbers is 2310 and HCF is 30. If one of the number is 210, then find the other number. Now there is a formula which we missed out actually during today's session. So please note down this formula. Everyone, please note down this formula. For two numbers A and B, product of two numbers is equal to product of their HCF and LCM. Product of two numbers A and B is equal to product of their HCF and LCM. Let's verify with an example. So if I take two numbers as 20 and 30, can I say HCF is 10 and LCM is of course 60? You can easily make out. So let's check whether it's true or not. So 20 into 30 should be equal to 10, that is HCF, into 60, that is LCM. Yes, that is true. So this is what we need to apply over here. Okay. This is the concept that we need to apply in this question. So now the question becomes very simple. LCM is 2310, HCF is 30. So let me just write down 2310 into 30 on the right hand side. Left hand side, first number is 210. The other number B is missing. So if we solve this one, we'll get 330 as the answer. Varshini, it should be 330. Okay, not 33. आप एक zero खा गए. Didn't you have your dinner, Varshini? Yeah, that's correct. Fine. So yeah. Now guys, why this is true? How did we get this relationship? Please understand this part. It's very interesting, huh? Why do we say product of two numbers is equal to product of their HCF and LCM? Isn't that miraculous? Are you not curious to understand that why is it true? Yeah, so let me explain this part, everyone. So let me take first number and pay your attention. This is again going to be slightly detailed. I'll not say complicated, it's detailed. Okay, so please understand this thing. Let's take one number as A and another number as B. Let's assume that HCF is H. Okay, so can I represent A as H into A and B as H into B? For example, if 20 and 30 are two numbers, so 20 can be written as 10 into 2 and 30 can be written as 10 into 3 because I know that HCF is 10. So I have written 10 into 2, 10 into 3 and these two should be co-prime with each other. Yes, everyone, are you with me? So same way this A and B should be co-prime to each other. Right? Okay. Now, what is the LCM? What is the LCM? So we always used to draw this ulta L. So it's H into A into B. Yes or no? Do you agree with this? Fine. Now let me multiply both sides by H. H stands for HCF. So HCF. I'm multiplying both sides by H. That is HCF. So left hand side is HCF into LCM. Now this one H into A is nothing but A. H into B is nothing but B. So that's how we got this result. Product of two numbers is equal to product of their HCF into LCM. Hence proved. Yes. We used to write this in childhood, hence proved, and we used to get full marks for this. Right, Varshini, that's sad. You didn't have your dinner. Okay, yeah, guys, that's the beauty of learning online. You can sit with your plate, right? You can sit with your idli sambar or vada pav or your dhokla or your balushahi, whatever you like, and you can enjoy this learning, isn't that? So there is no formality here. You can enjoy it. So guys, this is how we got this result. Once again, if you want, you can quickly take a screenshot and then we'll, then you can understand that later on. But we'll require to use this result in the next question. In this question, we'll require to use this. Now let me explain this question. So two-digit numbers. Please understand there are two-digit numbers. Okay, have GCD. GCD is nothing but HCF. Greatest common divisor kaho ya highest common factor kaho. Both are one and same. Okay. So HCF is 6 and LCM is 432. What is the largest of the two numbers? This is what we need to find out. Everyone. Yeah. Guys, don't put all these dishes in the chat box. I am feeling tempted. Huh? Right. So, guys, so how to solve this question? Let me help you understand this. Once again, we need to find out two-digit numbers whose HCF is 6 and LCM is 432. Right, and then we need to find out which is the largest of the two numbers. So one way is, of course, you can do trial and error. And what is the other method? So let's assume the two numbers are A and B. Okay, now their HCF is known, it's 6. So can I write down A as 6 into A and B as 6 into B? Do you remember we did for 20 and 30? So HCF is known, that is 10. So we can write down this as 10 into 2 and this 10 into 3. But here these two parts are not known. So I have written A and B instead of that. But HCF is known. So 6 into A, 6 into B. And this A and B have to be co-prime. Yes? Correct, everyone? Fine. Now, what is the LCM of these numbers? Of course, draw that reverse L, 6 into A into B. Correct? Okay. We know the LCM, it is 432. So write down 432 here. So 432 divided by 6, it's 72. So what we'll get? A into B is equal to 72. Please remember that A into B have to be co-prime. Right? So split this 72 in two parts, that they are co-prime. Of course, it's 8 and 9. So that's how I got A is nothing but 6 into 8 and B is nothing but 6 into 9, because I got A as 8 and B as 9. So my numbers are 48 and 54. So which is the largest of the two numbers? 54. Tick mark option B. Full 3 marks in CAT exam. Yes guys, kar sakte ho. Show me a thumbs up quickly and press the like button. It's wonderful, HCF LCM. And once again, if you want to learn, attend my this basic classes tomorrow at 2 p.m. So once again, I'm going to teach the basic part of this. Then I'm going to teach you HCF, LCM and factors and multiples and everything. We'll just talk about basic things over there. Right? So please do not forget to attend that. And you can also ask your friends. So guys, I have been requesting you to post about us about this particular CAT4MBA channel on your Facebook page and Instagram page. Have you done it? Show me a thumbs up if you have done it. Yep. Great. So let's take one more question. The greatest number of 4 digits which is divisible by all this number is, right? So guys, if I ask you, if I just eliminate this part, greatest number of 4 digit which is divisible by this one, just look at that. Find the number which is divisible by this one. So can I say we need to find out LCM of these numbers? Yes. So what is LCM of 15, 25, 40 and 75? How do we find it? So I'll suggest go by method of prime factorization. But before that, let me tell you quickly. Can I say 75 is a multiple of 15 as well as 25? So when we take LCM, we actually don't need to include 15 and 25. We will just find out LCM of these two numbers, and that will also be multiple of 15 and 25, because 75 itself is a multiple, right? Just say, for example, Pune is inside Maharashtra. Now, if you put Maharashtra inside India, so of course Pune has come inside India. It's like this. So 75 includes this 15 and 25. Okay, fine. So let's find out LCM of these two numbers. So what is 40? So, I can go by any method. So 40 can be written as 5 into 8 and 75 can be written as 5 into 15. So LCM will be 5 into 8 into 15. If you calculate, this will come out to be what? 1800, right? It will come out to be 1800. Yes or no? Everyone? 8 5s are 40. No, not 1800. Sorry, this will come out to be 600. LCM is equal to 600. So now we need to find out greatest multiple of greatest 4-digit number which is multiple of this 600. So that number will also be multiple of all these numbers. So it is 9600. Correct? Okay. Rajat, if you are not using any social media, you can ask your friends to do me a favor. Isn't that? Ask your friends. Your friends would be doing it now. So tell them, yeah, I want to post about this thing. They'll do it. But please post on your Facebook and Instagram page. Fine. So guys, I hope you have understood. The answer is 9600. Now let's take this one. Another variety of questions. So we are left with just 4 more questions and then we are through. So find the least number which when divided by 20 or 25 or 40 leaves remainder 2 in each case, right? Which when divided by 20 or 25 or 40 leaves remainder 2 in each case. If I eliminate this part, what will be my question then? If I just eliminate this part, find the least number which is divided by this one. That means you need to find out LCM of these numbers. So let's quickly find out LCM of these numbers. It's very simple. I can make out it's 200. Isn't that 200 is divisible by 20, 25 as well as 40, right? But we want remainder to be 2. So let's add that 2 over here. This is the answer. The answer is 202. As simple as that. Yep. Everyone, have you understood this? कर सकते हो ना ऐसे क्वेश्चन कि जब भी आपको पूछा गया है, whenever you are asked that find a number which is when it is divided by this leaves this remainder. So first of all find out LCM and then add that remainder into the LCM. Correct? Yeah, superb. Okay, so let's look at this one. Find the least number which leaves remainder 2 when divided by 5, leaves remainder 5 when divided by 8 and leaves remainder 7 when divided by 10. This is the interpretation of this question. Okay, read it once again, everyone. Let me just write it over here. Okay, so divisor and remainder. You know, there is a number which when divided by 5, it leaves remainder 2. When you divide it by 8, it leaves remainder 5. And when you divide it by 10, it leaves remainder 7. So what shall we do over here? So guys, whenever you come across such question, if you see it's a special question, look at the difference between this divisor and remainder. It's 3 over here. Difference between divisor and remainder, it's again 3. 10 and 7 difference, it's 3. So whenever you come across such question, what you will do is you will take LCM of this divisors, and subtract 3 from that. So what is LCM of 5, 8 and 10? Of course it's 40. 40 minus 3, what is that result? 37. So the answer is 37. See, if you divide this 37 by 5, you will get 2 as the remainder. If you divide this 37 by 8, you will get 5 as the remainder. If you divide 37 by 10, it's 7 as the remainder. Correct? Have you understood this, everyone? Good. So yeah, it was very hectic today. Yeah, so let's take a couple of last questions. Find the greatest number which leaves remainder 10, 8 and 6 when it divides 70, 80 and 90 respectively. See, whenever we talk about greatest number, mostly we'll have to find out HCF. Okay, so suppose that greatest number is X. So when X divides 70, it leaves remainder 10. So can I say X should completely divide 70 minus 10? X should completely divide 70 minus 10, right? This should completely divide. Same way, when that number divides 80, it leaves remainder 8. So that x should completely divide 80 minus 8. If you remove the remainder from the number will become completely divisible by the divisor. Same way, 90, so 6 is the remainder, so x should completely divide 90 minus 6. That means we need to find out a number which divides 70 minus 10 is 60, 80 minus 8 is 72, and 90 minus 6 is 84. We need to find out a number which divides all this number completely. See, remember that word divides, right? So that means we need to find out HCF of these numbers, and it will come out to be 12. Yes, guys. So I'll surely recommend you to watch this video again, sit with your notebooks and make sure that you just revisit all the concepts. Not only this video, watch part 1 and part 2 both. So tomorrow all of you should be spending about 2 to 3 hours in revising this thing. You know, morning mein 9 to 12 mein baith jao and you can do it. Acha, just for your information, everyone, in the morning, tomorrow in the morning at 10 AM, of course morning hai to AM hi hoga, I'm going to conduct one session on CMAT. So CMAT exam pattern, colleges and cutoffs. What are the good colleges through CMAT, right? So if you want, you can attend this session, and please ask other friends to attend that as well. So tomorrow 10 AM this session, 2 PM the basics of HCF LCM, and 9 PM, don't miss this 9 PM session. We are going to discuss remainders. Tomorrow we are going to discuss remainder questions of CAT. So I'll explain everything about remainders. You know, you will be able to solve even this question. So 5 raised to 175 divided by 7, what is the remainder? You will be able to solve all these questions, and these are asked in CAT, SNAP, CMAT, NMAT very frequently. So you should not miss that 9 PM session, right? Okay. So those 2 questions, I mean, I'll leave it for you for homework. This is an LCM question. Guys, I'm slightly tired, so we'll have to wind up today. I wanted to stretch it till 10:30, but yes, I think we'll have to stop here. And this one is also somewhere related to LCM. So please try for these 2 questions, and you can just post the answer. You can join the Telegram channel if possible. I'll try to post the solutions there, right? Yeah, Arunima, we are going to do it. So you will find all the PDFs by around Friday, Saturday. It will take some time because you know, we are just setting a system. So yeah, but we have PDFs of all the PPTs. Even the verbal faculty are going to upload their PDFs. I'm going to upload all my PDFs, whether it's a 2 PM session or 10 AM session or evening 9 PM session. We're going to make it available, and you can download it, right, without any worry. Okay, so guys, that's it for today. Let's stop here. Hope you would have enjoyed the session. And yeah, in case if you subscribe to this, if you take plus subscription, there are so many benefits. Do not forget to use my referral code, which is SHAH10. You'll get the discount. And these are our other courses. And don't forget to download this mobile app. It's very useful. Attend my special session. That's it.